Welcome to the third video of the Quarter 1 project on factoring. What we're going to look at in this video is when we have combined factoring methods, because they're not always going to be straightforward and they're not always going to be broken down based on the different categories. Like on a page you could have the difference of perfect squares, the sum of perfect cubes, factoring a quadratic trinomial. So you could have all these things on one page. So let's talk about the steps in order to make sure that you're doing the correct factoring method. Okay, let's first just take a look at things that we want to remember. First thing we want to remember is we always want to check for a GCF. Okay, no matter what, that should be your very, very first step. Always check for a GCF. Okay, the next one, we want to count the number of terms. So in class, you're going to get to do a little flow chart that will help you with this, but I'm just going to sketch one out real quick so you can do this last 2 pages of the project, and then you'll get a little more practice with this in class. So the first choice is if you have 2 terms, and if there are 2 terms, then your choices are it's the difference of perfect squares, so that a squared minus b squared, or you're going to have the difference of perfect cubes, so the a cubed minus b cubed. Remember, our tricks and methods to actually coming up with the factors are on the previous parts of the project in video 2, so I'm not going to write those out again. Or you could have the sum of perfect cubes. All right, and then you could have 3 terms. Okay, and 3 terms is going to be your quadratic trinomial. So our ax squared plus bx plus c. Again, that's in the first video, the methods for factoring our quadratic trinomials. And then if you have 4 terms, then you're going to be doing grouping. But again, you always want to look for that GCF first. Okay. All right, so let's take a look at the first one. Also to point out that there could be more than one of these methods. Not only are you having to choose the correct method, but there also could be several methods in one problem. So let's take look at the first example. So the first example is 2x squared plus 24x plus 54. So the first thing I'm going to do is I'm going to look for a GCF. Do I have a GCF for 2, 24, and 54? I do, and that number is 2. So I can divide out 2 out of each of these. Okay. So I'm going to write the 2 on the outside of the parentheses, and on the inside I'm going to write x squared plus 12x plus 27. Okay. Now notice I'm not done. I still have a quadratic trinomial in here that is factorable. So what we're going to do is we're going to use the method that we learned earlier, and we're going to say, okay, I have 27. What numbers multiply with 27 but add up to our middle number, which is 12? If you remember in the calculator, you can do that in the calculator by putting that in the y equals. So we're going to do positive 27 divided by x. Enter. Make sure you clear out anything that's already in there. So again, 27 divided by x, and then 27 divided by x plus x. Then we're going to go to the table. Okay, and we're looking for positive 12, so 9 and 3 multiply to 27, but add up to positive 12. So those are our numbers, 9 and 3. And remember, we're going to replace that middle term. So we're going to replace this term here with these. So now what you want to be careful of is this GCF we factored out has to remain. Okay, it doesn't go away, so I'm just going to write it on the outside, and then on the inside I'm going to still deal with what's on the inside of the parentheses. I have x squared, bringing down that term, replacing plus 9x plus 3x, and then I'm bringing my 27 down, plus 27. All right, and then on the inside I'm going to group. Okay, again, I'm going to write my GCF I factored out at the beginning on the outside. And then what can I factor out of the x squared plus 9x? I can factor out an x. And then I have left x plus 9. And then what can I factor out of here? I can factor out a 3. So I'm going to factor out the 3. Remember, you want to watch your sign there. You want to make sure you bring the sign out. This is a positive 3 we're dividing out, and that leaves me x plus 9. All right, and that was our goal here, is to get these two expressions to be the same because that's our common factor. And now we're going to rewrite. Again, we write the 2 on the outside. Our common factor, x plus 9. I'm going to write what's we factored out, x plus 3. Okay, so then that's our final answer. And again, you could multiply this back through and double check yourself, which I'm not going to take the time to do that. But please make sure that until you feel very comfortable factoring that you're checking. All right, let's look at one more. Okay, first we're going to look for a GCF. Is there anything I can factor out of here? So I have m squared times n plus 2m squared minus 9n minus 18. So if I look at all these, I'm looking at the numbers, and then I'm also looking at the variables. I don't see anything that I can factor out, so there's no GCF in this one. Then I'm going to count my terms, 1, 2, 3, 4. So I know for 4 terms I'm going to be grouping. Okay, so we're going to group here, group these guys together. This first 2 terms, we have m squared times n plus 2m squared, so I can see I can factor out an m squared. And then what's left on the inside is n plus 2. And then over here, okay, notice the signs are both negative, so I'm going to factor out a negative 9 from this one. And that's going to be n plus 2. Okay, I'm going to write my common factor out there in front. And then I have my next factor, m squared minus 9. Okay, now you are not done, because if you look a little more closely, I have n minus 2. Okay, that expression is there's not anything else I can do with that one. But if I look here, m squared minus 9, there's 2 terms here, and it's actually the difference of perfect squares. Remember, when we have the difference of perfect squares, we need to know what a equals and what b equals. Again, if you don't remember how to do this, you need to go back to the previous video. A is m, b is 3. And this first factor does not go away. I'm going to write that down, n plus 2. And then I'm going to write the factored form of my difference of perfect squares, which is going to be m plus 3, m minus 3. Now that is fully factored, and I am done. So please notice you're having to make a judgment call here, and then you also need to continue to look at the problem to see if there's anything else that needs to be factored. Okay, you are responsible for doing 16, 17, 18, and 19. Please be very careful. These are definitely a little more difficult. All right, there's one quick thing I want to point out to you. Notice that we haven't talked about things that are not factorable over real numbers. The reason why we haven't talked about that is you're not introduced to that until Unit 3. But I just want you to be careful, because if you see, we've talked about the difference of perfect squares. Okay, the sum of perfect squares, something like this, x squared plus 4, is not factorable over the set of real numbers. So what we want you to do if you see something like this is just write not factorable over the reals. In Unit 3, we will discuss in more detail what this means, but at this point, all you need to know is that it's not factorable over the real numbers. So the last part of the project is a factoring maze. I'm going to do the first 2 together with you so that you understand how to do this. So it says, beginning at the start box, make a path to the finish. You may only move a box below or beside. So below or beside, I can only move this way or this way from any box. Okay? If the 2 expressions have a common factor. Okay? I cannot move diagonally. Okay? So again, I can only move below and beside. I cannot move diagonally, and I can only move when the 2 expressions have a common factor. And then we're going to shade in the box just shade it a little bit because we need to be able to see your work to the path all the way down to the finish. Okay? All right, so let's take a look at the first one. So I notice this is the difference of perfect squares. So I'm going to move quickly through this because at this point you should be able to see better the patterns and pick up a little speed. We have x plus 1, x minus 1. So it's the difference of perfect squares. If I move down a box, I see this is x squared plus 1. So this is the sum of perfect squares, which I just discussed with you is not factorable over reals. So that's all you need to put there, so you know that there's not any factors. Now, to get full credit on this maze, you do need to be able to show all the work as you're moving down to the finish. If you just shade in random boxes, you're going to get no credit whatsoever. You need to make sure you're writing the factors in each box. Okay, so let's take a look at this one. If you look to see, this is a trinomial. So what we're going to do is we're going to look for factors of 4 that add up to -3. If you want to take a pause the video real quick so you can take a look at that and figure that out. It's going to be 4, -4, and 1. So that's going to give me x squared minus 4x plus x minus 4. I'm going to group. I can factor out an x out of the first one, x minus 4. I don't need to factor anything out of the next one, so that's just going to be plus 1, x minus 4. So we have x minus 4, x plus 1. Okay, and if you need to do the work on a separate piece of paper and attach it, that's fine as well. But make sure you're putting the factors in each of the boxes. So notice that I have x plus 1, x plus 1. So they match. So this is going to be the first step that I can make. Okay? Then you're going to do it again. Can I move to this box here or can I move to this box here? The only way that you're able to tell that is if you actually work the problem out, figure out what the factors, and then move to the next box. Eventually you will get down to the finish. Again, you need to show all your work and you need to write the factors in to each box. And that is it for the quarter 1 project. Make sure that you do all your work, show all your work, it's neat, and that you turn it in on time. Because remember, if you do not turn in the project completed on time, you will be required to take the test instead of turning in the project. And I can guarantee you that it is much easier to do the project on time than have to stay after school and take the unit test for factoring. If you have any questions, please come see your teacher during Wolverine time or whatever day after school they stay.